The elimination method. In this method, we eliminate one of the variables from the equations to get the value of the other variable. Let's now see how to solve a pair of linear equations with two variables by another algebraic method, the elimination method. First, we have to equalize the coefficients of y in both equations. This will help us eliminate the variable y from both equations. Since the coefficient of y in the first equation is 1, we multiply the coefficient of y in the second equation, which is half by 2. We now have the same coefficient for y in both equations. Now that we have made the coefficients of y equal in both equations, we can add or subtract the equations to eliminate y. Here, we add the equations. We see that x is also eliminated along with y, and we have 0 is equal to 13. Since this is a false statement, we cannot solve this equation. Here the system is inconsistent and the equations do not have a solution. Let's take another pair of equations and try to solve them using the elimination method. These equations have the same coefficients for x and y as the last pair of equations. Only here, the constants are different. To equalize the coefficients of y for both equations, we multiply the second equation by 2. We now add the equations to eliminate y. However, here too x is eliminated and we arrive at the solution 0 is equal to 0. This statement is true for all values of x and y. Here we cannot get any specific values of x and y. This is because both equations are the same. Since both equations are same, any values of x and y that satisfy one equation will satisfy the other. Here, the pair of linear equations can have an infinite number of solutions. We cannot find a unique solution to these equations. We saw two examples but could not arrive at a unique solution for any of them. However, you saw how the elimination method works. Now you should be able to solve a pair of linear equations with two variables by this method if you follow these simple steps.